Why do we need to find the inverse of a function? First of all, we need to have a couple things figured out. First of all, only those functions that are one-to-one functions have an inverse function. One-to-one basically means this, that every unique x, so every unique input has exactly one unique output or unique y value. Okay, so basically everything hinges on the y's now. Before, when we were determining if something was a function, it all depended on x. Now we're talking about every y value is unique here. Okay, so number 14 says this, is s of n equal to 1/2 n plus 12.5 a one-to-one function? Here's what happens. Let's say I wanted to make a table, and I have n and s of n here. Kind of like x and y, but because it's the notation, we have to keep it this way. And let's say I wanted to test these values. Let's say I wanted to test 1, 3, 5, 7, and 9. Okay? Now, we should be able to pick up if the output has a pattern here. That would help us determine if there will be a one-to-one relationship here, at least in terms of the unique x, unique y, unique input, unique output. Here's what happens. If I replace n with 1 here, I get 13 as my output. If I replace n with 3, I get 14 as my output. Same with 5, I get 15, 7 I get 16, and then 9 I get 17 here. Now we can tell that every time we go up by 2 on the end here, I go up by 1 on my s of n, my output. Okay? So in this case, because I end up with that, I can tell that every time I add 2 to my n values, I go up by 1. That means that there is a one-to-one function here, simply because this pattern will continue. Whether I go up, I increase n, or I decrease n, there will always be a pattern here, and there will always be a unique output for my function here. Okay. If we're talking about a visual test, so if we're looking at a graph of a function, determine if it has that one-to-one quality, we do the horizontal line test. Okay, and once again, just like we would see with the vertical line test to determine if something was a function, the horizontal line test helps me figure out whether or not it'll have an inverse. So if I look at these two right here, these two functions, this would be the function f of x or y equals x squared. Okay, so if I draw vertical lines, I'm going to draw one right here, another right here, another right here, and another right here. Now take a look here. Each one of these vertical lines goes through my function more than once. In this case, it fails the horizontal line test, which tells me that there is no inverse for this function. Okay, so that means this right here. Take a look. -2, 4 exists right here. +2, 4 also exists right here. Because 4 repeats, there is no inverse for y equals x squared. It is a function, but there is no inverse for it. And then if I draw vertical lines through this function over here, which is a discrete function or a discrete domain, notice how every time I draw in a horizontal line, there is exactly one value here. So that means that this passes. And that means that for this function, there is an inverse. Now, how do we find the inverse function of a discrete function like this? Or how do we find the inverse of a discrete function like this? Well, let's take a look. Let's say we have a function defined by the ordered pairs, -3, -1, -1, 0, 1, 1, 3, 2, and 5, 3. What are the domain and range of the function? Okay, well, the domain is just all my x values, which is going to be -3, -1, +1, 3, and 5. So all those positive odd numbers, positive and negative odd numbers. And then my range is just all the y values, so -1, 0, 1, 2, and 3. All right, take a look at this part right here, if you're following along in the Springboard book. Because inputs and outputs are switched when writing the inverse of a function, the domain of a function is the range of its inverse, and the range of the function is the domain of its inverse. Okay, so essentially, if we're looking at the inverse function, our domain and range basically just switch roles. So the domain of the inverse is now -1, 0, 1, 2, and 3. And then the range of the inverse is the old domain of the original function. So negative 3, negative 1, 1, 3, and 5. Okay? So what I want you guys to do at home is go ahead and do the check your understanding. We'll talk about the solutions to this, but think very carefully about what this means.